Hi, it's me again, Trish Juliano, and welcome back to my channel. So now we are down to the lesson 7 on complete AutoCAD training course for 2D and 3D. And for this lesson, this is the last method in data entering. So let's proceed. It is like relative coordinate that you enter the point with symbol at the beginning of your coordinates. So following this format, at distance, then angle sign, no? So the reference point is the last point that you have entered. So in this example, we have here point 1 and point 2. So if we are going to input this in CAD using the polar coordinate, we have to get the distance. So the distance between 2 points is 5, and our angle is from this 0 degree going to counterclockwise, so that is 30 degrees. So our format will be at 5 angle 30 degrees. So if we put this or input this in CAD, we are going to use this angle sign, which is the shift comma in our keyboard. So let's try it in CAD. So line L, enter. So don't forget to uh, do the line command, because it is the command that will make you draw a line. Okay, so we can select the location of our first point anywhere. So I will just click it here. So that is my location, the location of my first point. Okay, so after this, we will enter the coordinate of our next point. So that is at 5 angle 30, and then enter. So that is your line with endpoint at 5 angle 30. No? So this is the uh, AutoCAD drawing that we have made from our last lessons. So let's go back. So as you can see, we have here the direction of the angle. So think of it as a protractor. So this direction, the right direction, is always the 0. So from 0 going counterclockwise, the angle is always positive. So if you go clockwise, the angle will be negative. So it will be like this, and your line, you will locate, or you will enter the value of angle. So following these angles, no, using a protractor, or just remember how to use the protractor. Okay, so for our example, we will use the figure from our previous lessons. So this very same example number 1, we will try to draw it using the polar coordinate. Okay, so let's try point 1. So let's go back to CAD. Point 1, so I will try to put it in absolute coordinate first, the point 1. So L, enter. 13, comma 1. So this is the location of my first point. Okay, so let's go back to our drawing. So if it is going to the right, so this is the 0 degree, and the length is 3. So we have 1, 2, 3. So our distance is at 3 angle 0. So let's try it in CAD. So don't forget the at 3 angle 0. Okay, so that is your line. So next is point 3. Also, as we can see in the drawing, the angle is indicated already. That is 45 degrees. And the distance is 1.4142. So let's input this in CAD. So at 1.4142 angle. So what is our angle? 45. Okay, so we have that point. And then the next point is, so P4, we're going up. So that is 90 degrees. No? So 2 units going up. And the angle is 90 degrees. So let's input this in CAD. Up to angle 90 degrees. Okay, so our next point is point 5 or P5. Oh, as we can see, there is already there is a direction indicated in the drawing. So that is 4 units going to the left. So starting from point 4 going to point P, that is 180 degrees. So our coordinate will be at 4 angle 180. At 4 angle 180. And then, so we can just close the figure by typing C then enter. But we have to, or we need to get the coordinate of the last point. So I can really tell that we are learning. Okay, so from the figure, from point 5 to point 1, we're going down by 3. No? So this line from P5 to P1, the angle is negative 90. So since we are doing a clockwise direction here, no? From 0 to here to this angle, that is negative 90. Okay, so our coordinate will be at 3 angle negative 90. At 3 angle negative 90. Okay, so that is our figure. So these are the figures that we have drawn from our previous lesson. So this one is using absolute coordinate. So this one is by picking. This one is by direct distance. This one is by relative coordinate, and this one using polar coordinates. So as you can see, they look very the same. Except that these two, which are just assumptions. Okay, so let's proceed to our exercise number 1. So the figure 1, also the figure from previous lessons, we will get the coordinates of these points and then we're going to plot it in Autocad. So let's start the point A. Just let's assume that it is located in, we're going to use absolute coordinates. So let's assume the coordinate is 18, 1. Okay, so line 18, 1. Okay, so that is the location of my first point. So the point A. Okay. After point A, so we're going to point B. So that is 1. Now we move to the right by 1 unit and the angle is 0. So our coordinate is at 1 angle 0. At 1 angle 0. Okay, so going to the next point. So our next point is point C. So we move by 1 unit and the angle is 90. 90. So that is at one angle 90. Okay, going to point D. Point D is also 1 unit and that is 0 degree from C to D. So our coordinate will be at 0 or at 1. That is the distance. Angle 0. Okay. So going to letter E, we're going down. So 1 unit downward. And your angle is negative 90, no, from this direction. From 0, we're going downward. So we're going clockwise. That is negative 90. Okay. So at 1, angle negative 90. Okay, so from there, next point is point F. So point F, we're going to the right and the angle is 0. So that is at 1 angle 0. And then going to the next point, our next point is point F going to point G. So we have 3 units upward and our angle is 90 degrees. So that is um, at 3 angle 90 degrees. Okay, so going to the letter H, from G to H, we move 1 unit and the angle is 180 degrees now. From here going to here, that is 180 degrees. So our coordinate is at 1 angle 180. Okay. So we're going to the next point. Our next point is point I. We're going down by 1 unit and our angle is negative 90. Or we can also use the positive coordinate. So from here, we're going to um, count counterclockwise. So that is 270. So let's try using 270. So that is 1 unit downward, angle 270. At 1 angle 270. Okay, so next point. So it really doesn't matter if you use positive or negative angle as long as we have the correct value of angle to be input. Okay, so next point is point J. So from I to J, we moved 1 unit to the left and our angle is 180 degrees. So from point I to point J, the angle is 180 degrees. At 1 angle 180. Okay, going to point K. So we moved 1 unit upward. So that is 1 and our angle is 90. So we will input this at 1 angle 90. Next point is point L. So from K going to L, we moved 1 unit to the right and the angle is 180 from 0 degrees. No? That is positive because that is a counterclockwise. At 1 angle 180. Okay, and then going to the last point. So C to close the figure or use the polar coordinate, and the polar coordinate should be from L to A So we have 3 units downward. So we can also use negative 90 for angle or positive 270. At 3 angle, let's try the 270. Okay, so the figure now is closed. And so as you can see, we have three different, three the same figures, but using different entry date and data entry methods. Okay, so we are going to our next figure, and our next figure is also the figure from our previous lessons. So it is, as you can see in the figure, okay, so the angle here is indicated, the angle here is not indicated, and as well as in this angle, they are not indicated. So because these are not indicated, we are going back to the basic trigonometries to compute these angles. No? Okay, so AutoCAD is also math, so we need to go back to our previous math lessons to provide us answers for this type of exercises. Huh? Okay, so let's start at point A. So point A, let's just assume. No? Let's assume that our first point lies at 15 comma 1 or wait, ano yun? 15 comma 6. Okay, so that is the first location of our first point, the point A. So let's go back to the figure. Okay, going to point B, we have 1 unit to the right, so that is 0 degrees, right? 0. So at 1 angle 0. Okay. So next point, our next point is point C. So we're going up by 1 unit, and that is 90 degrees. No? So if we're going up straight, that is 90 degrees. So at 1 angle 90. So going to letter D. Okay, so there's no angle indicated. So let's go back to our trigonometric lessons, no? So just like here, we just compare. First, we just compare, so we don't have to compute. Okay, so from copying this from point F to G, so we have 45 degrees here, and we can see the horizontal change is 2, and the vertical change is also 2, no, as you can see, 2. So it means if our horizontal and vertical have the same value, our angle is 45. No? So let's assume since this is 1, our horizontal is 1 and our vertical is 1. So let's assume that our angle is also 45 degrees. So if we move if we write a straight line here, so from this straight line going to this line, so counter or clockwise, going clockwise, so the movement is negative 45. So let's try it. Okay, but we don't have the distance of this, no? Yan, so this is it. To compute the distance, let's go back to our basic trigonometry lessons. So, computing the C or the hypotenuse, so that is the C. We have the A squared plus B squared. So, since they are both 1, so 1 squared plus 1 squared, square root of 2. And the length of our C or our hypotenuse is 1.4142. So, ayan. So, kung gagawin din natin using the, computing the angle, so we're gonna use tangent theta. So, the angle here is theta equals A over B. So, that means A is the opposite direction, this one. The opposite side in the of the angle, and B is the adjacent side. So, we're just going to divide it, and to solve the angle, we're gonna use this formula. So, arctan A over B. So, 1 over 1. So, arctan 1, the answer is 45. Okay? So, let's go back to our figure. So, the distance of this line from C to D is, based from our computation, that is 1.4142, and our angle is negative 45. Okay? So, let's input this in CAD. At 1.4142 angle, so we're gonna negative 45. Enter, and then it's that. Okay, now we're going to the next point. Our next point is point E. So we're just going down. So that is at 1. So that is distance 1. Angle negative 90, or we can use positive 270. Okay, so let's input this in CAD. At 1, angle negative 90. Okay, so that is our point from E to F. So that is 2. We can see from the figure, the distance is 2, and our angle is 0. So our coordinate will be at 2, angle 0. Okay, so going to point G. So ayan, it is indicated in here. We can use the angle 45, and the distance is, okay, so we don't have a distance in here. So going back to our computation, okay, going back to our computation, so let's just replace this by 2 into, and we can also go back to in our exercise number 3. So they have the same uh, they have the same distance. So 2 units in A and 2 units in B. So we have 2.8284. So if we are going to compute this using this formula, so the answer will be 2.8284. And our angle is 45. So let's try it in CAD. At 2.8284, angle 45. Okay, so that is our point G. Point G. So going to H, that is 1.5 units going up. So that is 90 degrees. So don't forget to put at angle 90 degrees. I input the wrong. So at 1.5, angle 90 degrees. Okay, just 1.5. Okay, we're going to letter I or point I. The distance is 2 and our angle is 180. The H to I, the angle is 180. So the coordinate is at 2, angle 180. Yan. So we are near in completing the figure. So from I to J, we moved 1 unit upward. So that is, the coordinate is at 1. So our angle is 90. So at 1, angle 90. Okay, so next is ayan, J to K. So we also have 1 unit going to the left. So our coordinate will be at 1, angle 180. So at 1, angle 180. And then for our next point, that is K to L. So K to L, our horizontal distance is 2 and the vertical distance is 1. So we're gonna compute this using this formula. Uy, nagkamali ako dito. So that is 2. Ayan. Okay, so computing the C or the hypotenuse. So using the same formula, a squared plus square root of a squared plus b squared. So we will arrive at square root of 5 and our answer is 2.2361. And by computing the angle, so theta, our opposite side is 1, adjacent side is 2. So using this formula, our angle is 26.5651. Since this is from 180, no? So we will add 180 plus 26.5651 for us to get the angle of this line, no? Let's see from the figure, no? So from example, this is the 0 degree. So from 0 going to this direction, so that is 180. So we're going to add this angle. So we will have the true angle of this line, K to L. No? So what is our angle again? So 2656. 26.5651 plus 180. So our angle will be 206.5651. And our distance is 2.2361. No? So let's try it. So our distance is at 2.2361. That is the hypotenuse of our line. And then our angle is 180 plus 26.5651. So that is angle 206.5651. Okay. So we got the right figure for that. Let's go back to our drawing. So from L to M, we have 1 unit to the left. So that is at 1, angle 180. So at 1, angle 180. Okay, and then we're going to close this figure. So we are going to input this in polar coordinate to see if the figure will be closed it means that our coordinates are correct. Okay, so let's go back to the figure. So that is 1.5 to 2.5. So the distance is 2.5 and our angle is negative 90 or positive 270. So at 2.5 angle, negative 90. Okay, so our figure is closed. Oh, almost closed, no? So why is it almost closed? Not exactly closed. Because of the angle, no? Because our angle is 206.5651. Maybe, no? It has the numbers after those for the for decimal numbers, no, 0.5651. Maybe there are some other numbers, and also the distance of this line, we just rounded it off, so that means that is not the exact distance and the exact angle of this line. So it means that um so that is the since it is not closed, it means that we didn't indicate the exact value of our distance and our angle. Okay, so using the polar coordinates, it's really not this not we cannot close the figure unless we input the very um, exact value of our distances and angles. So it will be closed if our angles and distance have uh, exact value, no? Okay, so let's proceed to our next figure. Next figure, this is our last figure, and this is also the figure from our previous exercises. Okay, so let's locate the point A. Point A. So let's assume that our point A is at 15 comma 6. Ay, so that is the previous drawing. Let's assume that, okay, undo, let's undo. It locates at 6 comma 10. Okay, so that is the location of our first point, point A. So looking at the figure, going to B, we have 2 units going to the right, and our angle is 0. So that is at 2 angle 0. Ayan. Next point is B going to C. So we have 3 units upward. So that is at 3 angle, that the angle is 90. Okay. At 3 angle 90. Okay, going back to the figure. C to D, we have 1 unit to the right. So that is at 1 angle 1 or 0. Our angle is 0. So at 1 angle 0. And going to letter E or point E. So we can just copy this this value since it is it has the same horizontal and vertical distances. So our hypotenuse or the distance of D to E is the same with E to F, and that is 2.8284. And our angle is angle 45. So this is the angle 45 from this vertical line. That is the angle 45. So we need to add from 0 to 90, and then we're going to add 45 to get this angle. So that is 90 plus 45 equals 135. No? So the coordinate of point E is at 2.8264 angle 135. Okay? Okay. So at 2.8284 angle 135. Oh. And then going to our next point. So next point is point F. So we will use the same distance, and uh, our angle here is 45. Since we are from E to F, we will just uh, add 180 plus the angle 45. No? If we are going from 0, that is 180 plus 45. No? Okay, so our coordinate will be 2.8284 angle 225. So at 2.8284 angle 225. So that is your point F. So that is the point F. Going to point G, we just move one unit to the right, so our coordinate will be at 1 angle 0. So at 1 angle 0. And then going back to point A, we move 3 points or 3 units downward, and our angle is negative 90 if we are going clockwise, and positive 270 if we are going counterclockwise. And so our coordinate is at 3 angle 270. Ayan. So let's see if the figure is closed. The figure is closed, but as you can see, it has excess line, and that is again because of the distances of these two lines are rounded off. They are not the exact value. No? So that's why we have an excess in here. No? If we compare it using the uh, absolute coordinate and relative coordinate, so we can see that using the both um, using both relative and absolute coordinate, that our figure is really enclosed. No, there's no excess, and yeah. So for summary, we have uh, three methods: the picking, the data entry, or the direct distance, and the last one is the coordinates. So under coordinates, we have absolute coordinates, the relative coordinates, whereas we're going to input our coordinates using the x and y, And for polar coordinates, we're going to use the distance and the angle of that particular line. No? So this is the end of our lesson 7, and thank you for watching. Goodbye.